A very warm welcome to all of you. We welcome you for the session which is role of International Harmonization of Standards in driving safer and secure smart grid. This is in collaboration with US Commercial and UL Standards and Engagement. Welcome all, and I now pass on the mic to Anisha from US Commercial to take this conference forward. Thank you.
Thank you so much, Disha. I hope everybody can hear me. Good afternoon, everyone. My name is Anisha Shashidharan, and I'm the commercial specialist here at the US Commercial Service of the US Embassy, New Delhi. Today, it is my pleasure, first of all, to welcome all of you to the roundtable on the role of international harmonization of standards for driving a safer and secure smart grid. Today, we have a distinguished group of experts, policymakers, industry leaders to engage in this insightful discussion, share perspectives, and explore collaborative pathways towards a more secure and standard smart grid ecosystem. Without further ado, because we are already starting a little late, I would like to invite Nathalie Scharf, Deputy Senior Commercial Officer at the US Embassy, New Delhi, to deliver her opening remarks.
Thank you, Anisha. Does this work? Can you all hear me? Yeah? No? Doesn't work? Okay. I think it works now. Oh, good. Good. Thank you, Anisha. Well, good afternoon, everyone. Namaskar, distinguished guests and speakers, industry leaders, esteemed colleagues. Very nice to see all of you here today, and welcome to this technical seminar on the role of international harmonization of standards in driving safer and secure smart grids. I'm Nathalie Scharf. I'm the Deputy Minister Counselor in the commercial section of the US Embassy here in New Delhi, and there are several of my team members here that have worked with you to put this day together. I'd like to start by thanking all our speakers for their contribution to our discussion today and the future support in establishing a lasting US-India cooperation to really ensure safer and more secure smart grid in India. I also want to thank the participants who took the time to join us for today's roundtable to learn, to exchange ideas. I know your expertise on this very technical topic and your leadership will be instrumental in driving progress. So what we do here at the US Embassy in the commercial section is we work closely by tracking opportunities for US companies in India, and we help them enter the market, expand the market, and we connect them to Indian partners. And we do this through 7 office locations we have throughout India. So of course, New Delhi here at the embassy, but we also have offices in Mumbai, Chennai, Ahmedabad, Bangalore, Kolkata, and Hyderabad. So as we know, the energy sector in India is really undergoing a rapid transformation. It's driven by the 3 Ds. The digitalization, decarbonization, and decentralization. As the country advances their smart grid initiatives to meet the growing demand, the need for internationally harmonized standards has never been more critical. Smart grids are the future of energy, making electricity supplies more reliable and efficient. And with increased digitalization, they also face risks, particularly in the realm of safety and security.
Thank you.
And to ensure that our smart grids remain safe and resilient, countries need to work together to develop common standards. So today's roundtable will serve as a vital platform for all of you who are experts, policymakers, and industry leaders from our nations to exchange really your insights, share best practices, and explore pathways for deeper cooperation in standardization efforts. By sharing our expertise, best practices, and lessons learned, we can really create a framework that fosters interoperability, mitigates risks, and builds trust in the smart grid infrastructure. So today we aim to foster dynamic and productive dialogue. We would like to identify concrete steps that can be taken to enhance international harmonization and strengthen the smart grid ecosystems. So I encourage all of you to participate actively, to share your insights and contribute to the development of some actionable recommendations at the end of this event. And I would like to conclude by thanking the UL Standards and Engagement for partnering with us, my team here for putting together this roundtable, and a special thanks to the ISGF team, Reggie Pillai, not here yet, and Reena Suri for their active contribution in this sector. This marks the 11th edition of the India Smart Utility Week, and we look forward to continuing our partnership with ISGF for many more years ahead. So I look forward to this engaging discussion, to the meaningful collaborations that will shape the future of smart grid security. And I thank you all for being here. Let's make this a productive and impactful session.
Thank you so much, Nathalie. Now, may I request Ms. Sonya Bird, Vice President, International Standards for UL Standards and Engagement, for setting the context for the session. Thank you.
Thank you. Is mine working? Yes? Okay, perfect. Thank you. Namaskar. As the introduction there, I am Sonya Bird. I'm with UL Standards and Engagement and the Vice President of our International Standards team, meaning that I work very closely with our partners around the world in the introduction of UL standards to help address safety, security, and sustainability globally. I'm very happy to welcome you here today to this Indo-US bilateral roundtable on this important topic, role of international harmonization of standards in driving safer and secure smart grid. I think we get paid by the word. We have had a fantastic response on this topic from a series of dialogues we have facilitated with our key partners in the last year. And I'm delighted to see such a diverse and esteemed group of participants in the room today representing key stakeholders to this important endeavor. We're very thankful to the U.S. Commercial Services and India Smart Grid Forum for working together in organizing this roundtable discussion, supported by Bureau of Indian Standards. We are pleased to join the annual event, India Smart Utility Week, an event today considered as one of the top 5 international events on smart grids, electric mobility, and smart energy. It is a testament to the shared commitment of these organizations to driving solutions for a safe and secure smart grid. As I mentioned, I'm UL Standards and Engagement. Our organization has seen many changes since its founding, most significantly and recently in the year 2022, when Underwriters Laboratories launched 3 independent organizations, clarifying the unique role that each organization plays in working for a safer world. The first organization is UL Solutions. That's the group that many of you know as a testing, inspection, and certification body. They are responsible for testing and certifying many products, and UL Solutions has a strong presence here in India. There's also UL Research Institutes, a nonprofit organization looking at research for safety issues on the horizon. And then there's UL Standards and Engagement, my organization, a nonprofit international standards development body and safety advocacy organization. We've published standards for more than a century. Our very first standard was published in the year 1903, and we continue to create standards and awareness and forge partnerships to help enhance safety, security, and sustainability globally. And I'm pleased to share that we have a team of 4 staff working for UL Standards and Engagement here in India. India is a very important area of focus for us. Safety science is at the heart of what we do. we put safety science into action by developing standards and policies that play an essential role in preventing injuries and saving lives across the globe. Our catalog of more than 1,700 standards and guidance documents leads to positive safety impact globally. As a consensus-building body, we bring together leading minds, such as those in the room, to create standards that improve safety, security, and sustainability across the world. We are accredited in the U.S. by the American National Standards Institute, in Canada by Standards Council of Canada, and we are authorized by DGN in Mexico to develop standards for Mexico. These accreditations show our compliance to the WTO TBT Code of Good Practice for International Standards Developers. Safety is a shared mission, and it's one that we pursue across the globe. Our capacity to create change is amplified by the partners who join us as technical committee members. For this reason, we've built a unique network of researchers, scientists, engineers, technologists, consumers, and businesses to provide a variety of expertise and perspectives. Their input helps us shape comprehensive standards that make products and systems safer. As we gather here today, we must recognize that building a robust safety smart grid ecosystem is not merely about electricity distribution, but about changing the way we think about energy. It's about ensuring that our power supply is more reliable, thereby making our cities more resilient. This is a shared mission that transcends borders, industries, and sectors. As of January 31st, India's solar power installed capacity is 100.32 gigawatts. India has become one of the world's fastest adopters of solar power, making it the third largest producer of solar power globally as of 2024, after China and the United States. I would like to congratulate the Government of India for introducing policies aimed at installing rooftop solar systems in 10 million households over the next 3 years. I understand that already 1 million installations have been accomplished. For successful implementation and safer grid integration of DER, standardization plays an important role, and we want to congratulate BIS on the successful adoption of IEEE 1547, and we're happy to note that that standard references a ULSE standard 1741, and we're pleased to be part of that. Other essential factors to consider are cyber attacks on DER, and ULSE Standards and Engagement is integrating cybersecurity requirements with the new publication, UL2941. A collaborative approach for safer grid integration, including all stakeholders, shall facilitate learnings and evolving solutions and best practices for safe, secure, and sustainable integration of DER. At UL Standards and Engagement, we are constantly looking forward to more participation across our technical committees who could help add specific inputs to our standards process. And I invite you all to consider applying to become a technical committee member or a stakeholder on one of our technical committees. Today, as a key partner at this roundtable, UL Standards and Engagement aims to contribute to the development of Indian smart grid standards and policies, aligning them with global best practices. Our mantra, One Globe, One Standard, emphasizes the importance of collaborative efforts and the global harmonization of standards. Together, we can create a sustainable future where economic growth and environmental stewardship are mutually reinforcing, ensuring a better world for future generations. To further advance this agenda, we've come here together today, hoping this platform will facilitate the sharing of vast knowledge on technical contributions and best practices adopted globally. We aim to explore further collaborations to work towards building globally harmonized smart utility, mobility, and infrastructure for tomorrow. Thank you again for your participation, and I look forward to the inspiring and productive discussion. Let's work together to make this vision a reality. Thank you.
Thank you so much, Ms. Bird. May I now request Mr. Ashok Rajput ji is here. Right, exactly, right on time. Yeah. That's okay.
New device.
Yeah. May I now, may I please introduce Mr. A.K. Rajput, former member, Power Systems CEA, to address the keynote address. Thank you so much.
Yes. No, I don't need any minutes.
So you can settle down for a...
No, I have to silent it, otherwise it will disturb. Protocol. Protocol has to be followed. Yesterday it disturbed a lot. So today zero sound. Right. Thank you very much. Good afternoon. Namaskar. मेरा अभिवादन स्वीकार हो. Abhivadan means this. Yes. So we are sitting in this international forum, and we have to speak. Or give me how many minutes I have to speak?
Sir, I would prefer if you can limit it to 10 minutes.
5.
10 minutes is what?
5 will be enough. Yes, 5 will be enough. 2 minutes extra. 2 minutes incentive. 7 will be okay. So time management has to be there. So I have to talk and present my views before your kind self about the international harmonization of standards in driving safer and secure smart grid. First of all, we are yet to define, I think, the smart grid, what the smart grid is. Still the definition is not formed up. Similarly, the definition of the smart meter, that also is a very loose definition. So many definitions are there, and it depends from person to person. So that is where we have to bring an unanimity that what the smart meter is, which is one of the component or the important ingredients, basic foundation block of the smart grid. And another thing is that what will be the building blocks and its seamless integration in a safest way as far as the performance and the operational requirements of the smart grid are concerned. So we should start from there, and I think we have to start again from zero, since past so many years we are still struggling what we are doing. When I started my journey for the smart grid and this India Smart Grid Forum, it was forum headed by Raji Pillai Saab. I have been the founder, making the papers, means the voting papers for the organizations. It was constituted here only in the Chandralok building in the office of PFC, Power Finance Corporation, at that time. So that's the association. Pondicherry project is said to be a driving force where at least 40 or more than 40 companies participated for integration, experimentation, and getting the extract out of it how the smart grid will be in the future, to decide the future roadmap. Of course, very good learnings. Then parallelly, the same day, or you can say the same time, India Smart Task Force was also created, ISTF. That was a totally government body, secretariat provided by erstwhile Power Grid, still it is Power Grid, PGCIL it was known at that time. So the two agencies, the concept was very noble that one organization, one institution work in the government sector, and one institution, mainly this ISGF, at that time the concept was given that it will be consisting of individuals, academicians, and the industry participation. No fee from the academicians. That was the biggest strength. So that something comes. And that something came also, and Raji Saab is leading it, and his team, now his team is quite capable, quite large, quite big team, and a very knowledgeable team, I would say. I keep on interacting with them, so that is my smartness, that the company, or you can say not, we should not talk of the company, we should talk the institutions. So institutional framework is there. That time the roadmap by China for the smart grid was building the large dams, building or constructing the power highways at extra high voltage and the HVDC, use also of the STATCOMs and the other devices, and going where, taking the power from the remote locations to the load centers and driving the industrial growth. So every country followed its own model. So that was the Chinese model which we studied in detail. In the field of smart grid, we were already smart to some extent. Power grid at that time, and for example, many of our power generating utilities, they were having all sorts of controls, say right from the SCADA, you can say, that is the one basic thing that was already in existence in our system. Prior to that, we were having some microwave communication system, but that communication system was transferred to the defense. We opted for the communication highways or the communication backbone, say starting from 400 kV and upwards. First OPGW in the central sector, then OPGW in the state sector, and right below up to the 66 kV at least. That thing continues, still continues. Since we have a communication backbone and the redundant and independent communication system, a very robust communication system, without that we cannot think of the smart grid. That's the basic building block that we should understand. Only the components, devices and the sophisticated devices, they cannot make the smart grid. Smart grid is a concept basically which has to be integrated, which has to be harmonized, which has to result into the functions. We should know what functionalities we want. Bottle is here, I have to open it, it's a mechanical way. Maybe some smart way may come, it can get opened, it can do this thing. That is the extreme end of the smartness. But the smartness has gone into it also, because the purified water, whatever has come, it has monitored, it is continuously monitoring wherever it is being packed and it is being processed. That is the another way of the smartness. So smartness is into each and everything. Earlier the simple automobile, clutch and gear, ABC, that is accelerator, brake and clutch, and that is the safest I feel so far. And now the automated, gearless, and now the driverless. So you have to define your limit and what is your objective, and how much you can invest, how much you can maintain. If you are not able to maintain your smart grid, whatever you develop today, it's a waste of money. It should not happen. You have to maintain it simultaneously. You have to make it cyber proof and all those things, because the hackers are already there. They are looking. Wherever you miss, they will find their scope. So transmission systems, our transmission systems were quite smart from the very beginning, you can say. Then came the era of the unmanned substations that we have, the remote monitoring of the substations. Smart grid nowadays, when we talk of and comes, and as the journey progressed, we gave lot of emphasis that the smart grids, oh, I think time limit 2 minutes more, है ना? Time limit. I'm speeding. Abhi hai. Yes. Sir. So we focused more on a simple device known as the meter, and we thought that the meter will do wonder, and we will hang the meter, usko hang karenge, and meter will ultimately commit the suicide. We will burden the meter too much that ultimately it will commit suicide. Meter itself, it will become so live and so smart. So the human needs, the human objectives, the human greed will kill him. that meter. So constantly we are emphasizing meter, 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 meter will do this, meter will do that, meter will do this, who has entered, who is entering into our house, he will take that photograph also and all those things, so many things. It will supply the data. Of course, very good, data will be supplied to the listener, but for that also we need the communication system. Now the problem has come, it has to be interoperable, it has to be, say, independent, it should not be technology limited or the vendor limited, vendor locking should not be there. So many things are there. Whatever the smoothness is coming on this floor, we are talking of this and this, that it should have the colorful flowers also looking like the real one. So that is what we are doing with the meter and the metering technology, HES, MES and all those things, MDM systems. But no one is thinking that how much is the expenditure on maintaining this system and the recurring expenditure, and how much commensurate the revenue as a electric utility, particularly the DISCOM, who is already stressed in so many things, how much from per node or per meter they are deriving the revenue. There are other means also. Fundamentally, when we started distribution reforms, metering was one of the concepts that metering need to be improved. There is a lot of scope in the metering, and of course there were many loopholes, so many tampering of the meters were also there. So earlier smartness, model of the earlier smartness, how to arrest the temper of the meter. And those tampering, whatsoever the known methods of tampering is there, the logics were built in, all the logs are available, but from those data, there was no one or the utility, most of the utility lacking, that we carry out the analysis of that data and identify what is going on, where the tampering actually has taken place and what has been the cause of the temper and all those things. So that is lost. So we have gone much more ahead. The load control, if the bill is not there, or say take the case of the prepaid metering, if say I forget to pay the bill, then my electricity will be off. It's basically advantageous. Say for a few days if the electricity is not there, at least some mental peace will be there. Phone will be away, TV will be away. So that's a lighter part of it. But consider the case if COVID and some that oxygen concentrator is running there, and that concentrator is a must at that time, and also for the old patients, those who are having some treatment at home and are dependent on that. So consider that if the electricity is cut off, so all of a sudden, and you are busy here and there taking care of that patient or busy in some other things, as I got busy right now in coming here and forgot to pay the bill, my electricity is off, I am nowhere, how to get it done. And I have to criticize myself also, for to some extent also, to the utilities also, very frankly, and it's also very easy to criticize others, and doing something better is more difficult. So I can criticize this way, oh, these electricity utilities, they have not cared, and my electricity is off without fault of mine. They should have given some concession period. Of course, they give concession period, they give the message also, but your phone is already full with so many messages. You have not filled this bill, you have not completed this bill, and so many say message comes for making the money too early. That is the another type of smartness. You do this, you press 9, you press 1 and your account goes there. So that's also the disadvantage of the smartness. So we have to live a simple medium path. So medium path we have to follow. Thing is that if we have adequate human resources available with us and they are trained properly in doing certain thing where the manual labor can do something honestly and ethically, as a first choice we should keep them, engage them. Wherever the manpower is a problem, lot of data, lot of revenue potential is there, and if they do some manipulation with that metering data, whatever the metering information, we should opt for the highest end of the technology. So we have to be decisive. In that management terms, what we learned in the beginning also, it was called as ABC analysis. You identify your consumers when it comes to the distribution, who are the consumers, they will be very less in number, say 10%, who is giving you say around 70% of the revenue. That is the A category. B is naturally slightly scaling down, and C you don't bother. They will do 100 units they are consuming. Already government is making the 100 units free. Why are you putting smart meters and wasting your energy and the technology and the resources? So that is this. One more thing, and I would say the ethics has to be maintained, data privacy has to be maintained. Of course, the Data Privacy Act is also there in the country, and we are habitual not to maintain and not to follow any act or laws. Okay? We have to be again trained, and again another act has to be brought so that we start following whatever the existing act is there. So that process goes on. That is also a process. No? They have been elected, democratically elected. They have to make the rules and regulations in the parliament. So their job should also continue. So we should break the law. They will bring the another law. That also is a case. And to plug those holes, we have to take help of the technology. And that's the smartness. Right? That's the smartness. So that smartness we should do this. Smartness with a human content is the biggest form of the smartness. At least some human considerations should also be there when we are devising certain things. And the example is 17 paisa bill came from some my mobile service provider, right? Similarly, maybe in the electricity also. So message came, you have not paid the bill, your phone will be disconnected. Okay, I realize it, I am late. So usually what I was doing, if it is 315 and say 52 paisa or like this, so next higher digit I will pay. So I kept on paying. 17 paisa I thought they will not mind. Again the message came, since your bill has not paid, your services have been discontinued. 17 paisa. So it is all technology. So I do not know what technology solution we experts, I am one among them, the least knowledgeable person, part of all this system, doing something, agreeing to the majority, and that's the smartness. And without any disruption, without any making anybody unhappy, and that's also an smartness. That should be learned. Capabilities of the human beings have to be increased, and the level of education and the new things and the new technologies they have to learn, but do not forget the fundamentals. Thank you. Jai Bharat.
Thank you so much, Mr. Rajput. It's always a pleasure hearing you.
Thank
And
you.
I'm glad you were able to make it on time.
हाँ इसीलिए मैं बोल देता हूँ पहले इशारा कर दिया करिए अदरवाइज माई वंस ट्रेन स्टार्ट्स इज स्टॉप्स इज समटाइम्स पास लीव्स द स्टेशन गो टू द नेक्स्ट स्टेशन
Okay, thank you so much again. And now we'll move to the panel discussion. So for that, I would like to invite Mr. Richard Schomburg, Special Envoy on Smart Electrification IEC, to share the European experience.
Good comfortable. I think you have been pushed into the corner.
right. It's like, yeah, no, okay, it's going to work. Don't worry.
Yeah.
Thank you. Thank you, Asha. So, well, thank you very much for the invitation. It's a great honor. Actually, when I received the invitation, I kindly responded that I'm sorry, I'm not going to do that presentation. Well, there is one good reason, because as representing the IEC here in this event, IEC is international, it's not European. There is a misconception about IEC being too much or being European. So for that reason, I responded, I'm not going to do it. But I was kindly re-invited after lunchtime, so I said, okay, I'm sorry I did not prepare any presentation, but I am very happy to contribute to the theme. And how much time do you give me?
So we would appreciate if you could complete it within the 8 minutes time frame.
How many?
8 minutes.
8.
8, yeah.
8, okay. So let me set up my timer, because as I did not prepare, it's very risky for me. I'm going to do a balancing act before your very eyes. So actually the theme is really harmonization of standards and smart grid. And you know what? We keep talking about this topic for a long time, but we keep developing new standards, and we keep having multiple standard development organizations meeting on a recurrent basis, saying, oh, we want to harmonize, but let's keep developing new standards. Well, that's fine, because actually, for full disclosure, I'm a utility person. I have had a very long career as a utility person, as executive. And of course, the issue is that as soon as the smart grid concept has started, what was striking for a utility person is, hey, if you start a smart grid project, this requires to reference a large number of technical standards. A large number of technical standards that could come, of course, from IEC, but also from other SDOs. And the issue for utilities or for the practitioners who are supposed, you see, to be happy, to be made happy, despite themselves by SDOs. Okay, what do you do? And I have been acting and promoting within IEC to really consider putting in place new processes. And this is really what we've been doing since 2008 at the IEC. Well, my background was system engineering of complex systems. And as soon as you digitalize anything, it's becoming complex, so complex because it's invisible. And this is human nature. When it's invisible, it's too easy to dream and even come up with a chimera, things that actually are not even feasible. Okay, that was my experience on complex digitalized systems with the instrumentation and control system of nuclear power plant. And I've been the designer of the INC systems of the French fleet of nuclear power plant. I realized that the system engineering know-how that was developed for this nuclear industry that had a lot of resources actually would apply and resolve a lot of the challenges of the so-called smart grid. And this is where, at the IEC, I have promoting and I have been pushing all the IEC players to start considering this new concept of smart grid and start some standardization, dedicated standardization work. And as soon as I started to do that, a lot of existing technical committees were saying, but there is no need because I am covering it. They all were covering part of it. Even the technical committee on thermostat was saying, no, but no one should work on that. It's our job because through the thermostat, when I look into the thermostat, I can see the entire chain. Okay, so this is where we came up with this idea of setting up a strategic group on smart grid. It was actually a US proposal at the beginning. It was a US proposal, and then the US wanted to take over this and lead this. But actually, now for full disclosure for the story, my affiliation as my employer was EDF from France. I said, wait a minute, I have been pushing and advocating to create that, and now the US National Committee wants to take over, and they said, they requested the French National Committee to nominate me. So I have been starting, and we've been doing a lot of work, putting in place new processes that did not exist in standard development organization. And what's the purpose? It's actually to review existing standards, try to map them, try to position them in between themselves to identify gaps, overlaps, and to actually plan and discuss with the owners of the standards within the SDO to plan maintenance of those standards to try to bridge gaps or overlaps. and also put in place what would allow to avoid new gaps and overlaps for new standards to be developed. And for that, I requested to have very specific people in this strategic group. Those specific people, well, I wanted even the resume of the candidates to be in that group, which is not allowed. I mean, within IEC, national committees decide who they are sending to the committee. I said, no, I'm going to do it, but I want people who can have enough experience. So in the end, what I got, it was incredible. I got the CTOs of big names companies. Oh, I see Siemens here. Oh, I've seen this company name somewhere. So, well, okay. We got 13 CTOs of big name companies, and it was just incredible. In very few years, we started, you see, very quickly to organize the thinking, align, and immediately people were saying, oh, it's very easy, let's make drawings. Let's make drawings to map what exists, etc. The issue very quickly is that there is no drawing that was able to move forward for a very simple reason. Drawings are 2 dimensions, but we were dealing with issues that had much more than even 3 dimensions. And this is where we came up with the idea of saying, you know what, we need to have the computer doing the heavy lifting for us. We came up with a smart grid system and a mock-up, so it's something else. If you want to convince people and engage people, it's not just discussing or coming up with concept. You need to put on the table a kind of mock-up that shows that everybody can see the same thing and shows what it can do. And then people come, join forces. And this has been going on for years. It is still going on. But also another takeaway is this kind of effort is huge. It requires a lot of resources, and it's very difficult to have this recognized by the resource providers. A lot of companies or national committees, they are okay to send out experts to deliver new standards, not to do some miscellaneous work. But I think this so-called miscellaneous work is absolutely fundamental. It's enough to have again and again a bunch of standards developed everywhere on anything, and like if it's a race to publish the buzzword or the most exciting new standard. I will stop here because I have a signal, and also I had 4 more seconds on my personal timer. But I hope this can be actually of use for this discussion.
Thank you very much, Richard. Thanks for bringing up that it's the IEC experience that you're sharing. Anyway, we have Dr. Miguel who is there, who would be able to talk about even the Europe experience. Kishore, we'll wait for, because we have the round table. This is actually just to set the context.
Just one sentence to add to what he has, to sum up this thing. I think what you're talking of is system standard than product standards. And I think harmonization is all about system standard rather than product standards. I think just that, nothing more.
Thank you. Thank you, Kishore. Thank you very much. Thank you, Richard, once again.
Just one more thing. Actually, sometimes what happens, too many cooks. Okay, we have to be very, very careful. And,
Thank you, sir.
And the committees, panels and sub-panels, then comes an element of ego also in the formulation of standard. That has to be minimized. Okay? Otherwise, neither your standard will be formulated, nor your standard will be good. Very, very frank opinion. Right, sir? And this I have seen, telling out of my experience. We spoil the whole things, and we spoil the country and even the country's stakes. One more thing, standards should not be framed in such a way that it monopolizes the things and only for the commercial gains. That should not be That is a teaching or preaching, whatever you say, but it's an open thing and a very blunt thing. People won't say it on any forum. Another thing is recognize the potential and the feedback at least of the user. There is no feedback mechanism when the standard is getting implemented. On whom it is being applied, from whom the system is getting generating the revenue, his say is not there in formulation of the standards. Only some complex things are done. One more thing which need to be clarified is IEC is naturally a global body. I think how many countries are there now? Earlier used to be 152 or so.
Even more, I cannot count them.
Not count them. Okay. Okay, because you cannot count because some country got divided.
Yeah, maybe. Well, that's another discussion.
Another discussion. Say like Yugoslavia was only one country. Now there are 3 countries. So like that. Anyway, but we all technical professionals are united. And what I wish to tell here, we use the FPS system. I think US still is using the FPS system. Then came the MKS and then SI system. That is the basic harmonization. And now as far as my information goes, past 2-3 years, the definition of electric current has also changed. So out of sheer interest in this particular subject, I am knowing. But in my organization, nobody is knowing that the definition of electric current has changed. They retain the old definition only, right? So that is the standardization. So whatsoever standardization is being done, it need to be made aware, and simplification, simplified guides also, some awareness campaign also to be made. In India, I have seen one example how it gets simplified, conducting at least hundreds of workshops in different towns and colleges. That's on National Building Code. National Building Code, though it's not a mandatory document here, it gets mandated when any of the municipality adopt it, like that. That is this one. So that contains your EV things, your lighting, your rooftop, and so many things, lighting protection. That's I am talking of the electrical chapter. Fire is different, and like that many chapters, and like safety, exit route. Suppose you are trapped here somewhere, how to exit in emergency. So we should think of such high standards and say when smart grid is said to be self-resilient or the self-healing, but that self-healing properties is yet to be realized. How it is healing?
It reconfigures.
Yes. So that is where the expertise is required. So one I was to say this MKS FPS business, another is IEEE ANSI one side, one word is IEC. I fail to understand. In India, IS we are trying to harmonize with the IEC. We have got just 1 minute. We have got many standards in our ETDC, Electrotechnical Division Council. Either we have harmonized large number of them, and if not harmonized, we are say adopting 1-to-1 in dual number schemes, and further whatsoever are left, we are working on that. But this IEEE, IEC still we fail to understand how they are doing and how they will go ahead.
Ashok sir, sorry Richard, I'm sorry to cut because I think we have limited time, and also we need to really bring the discussion of DER integration, and that's where how the standards harmonization can help, because they rightly brought out is like the IEEE or IEC, the European experience or the US experience. I think you have already set the context in terms of understanding what the IEC harmonization perspective. However, keeping the topic that we are really dealing with is the DR integration and what are the standards that have been used and what is their experience in US. So now I would request Mr. Douglas.
But remember, 1 volt and 1 ampere is same in US as well as in IEC world.
Thank you so much. I will now request Douglas Arendt, Executive Director, Emeritus, NREL Foundation, to share the U.S. experience.
Yeah, thank you. I'll be brief because I'm actually joined by a colleague online who's one of our one of NREL's technical experts. But let me explain just a bit for those of you who do not know what NREL stands for. It's the National Renewable Energy Laboratory. It's one of the Department of Energy's 17 national laboratories that's been focused on clean energy, transportation, buildings, power for 48 years. It's about 4,000 people, and with about $25 billion worth of investment in facilities and knowledge and capabilities. I was there for about 30 years as an employee and am now emeritus, and run an independent but affiliated nonprofit called the NREL Foundation, whose mission is to leverage NREL but to advance that mission space by working more closely with corporates and with philanthropy around the world. I'm going to provide just a couple of reflections given that history and some of the opening remarks, which is that the constant dialogue over the definition of smart grid started nearly 20 years ago, when it was the exact same comment. We don't know what smart is. We don't know how to define it. And I will reflect that that definition continues to evolve. And I think that this is important because the technologies and the IT system capabilities continue to evolve. And therefore, I think we have to come up with what I think are the common characteristics of what smart means. Sensing, measuring, monitoring, ability to control, perhaps actually the ability to predict and have forecasting capabilities. And all that is coming much more to fruition. And I'm going to expand just a little bit from the DER focus and reflect that smart grid also means something very different to those that manage an HVDC system or the big backbone of the system. And there also technologies are changing because we now have dynamic line rating capabilities and sensing capabilities. And it is important to understand that the integration of from DER integration all the way up through TSOs has to be seamless. And that if a TSO has to manage a large bulk system and propagate control signals down that might actually go into a virtual power plant and an aggregation of DER resources, that means that there must be harmonization of standards, if you want to use that term, or at least adaptation of those into systems that integrate across DSO, TSOs, and DERs. And so there is a constant need for work to adapt and evolve these as technologies continue to advance, and particularly as we adapt more very smart IT-based systems to manage this going forward. And so there has been, in the last few years, I'd say, additional recognition of the bulk scale and how to make the bulk scale, the wholesale backbone, smarter, i.e. grid enhancing technologies, which again are working at that level but have to reflect and connect back into the DERs. And this whole evolution of DER integration and aggregation capabilities is a huge step forward, but needs mindful, thoughtful dynamics. There are a couple of reflections from around the world that, from our experience, having worked in Australia, even Africa, et cetera, pay to play metering, very important. Early DER propagation of inverters, which did not have or did not allow visibility of the system operator to see them or even control them, or having a rule in place to be able to curtail them if needed. Those are all really very, very important early lessons that need to propagate forward. And even further today, about two-way power flow. So there's a nice V to G showcase here. That will only evolve if rules standards are clear for integration, along with, for example, and something that I haven't seen a conversation about here yet, but if you look at Europe, it's called balcony solar, which is just propagating out. And so this is essentially anyone available to go buy a panel with an inverter on the back end of it. Is that allowed? Is it not allowed? Is it able to inject power? At what level? Is it able to be visible or controlled? All those things need to be decided by both technology standards and rules about how that goes forward. So those are my reflections. Andy, are you with us? I want to introduce Andy Hoke, who's one of our senior electrical engineer who has been very deeply involved in IEEE 1457 as well as 2800, and was very involved also in the work with BIS, MNRE, and many others here about adapting or making a recommendation of adapting 1547 for India. This is now a little while ago that you have already accomplished. So Andy, are you with us? Can we turn on the microphone from the online meeting?
Hi everybody, can you hear me?
We have to thank him for being up at 2 in the morning. Go ahead,
Is my
Andy, we
audio
can hear
coming
you.
through? Okay, great. Yeah, thanks for the introduction, Doug. I'll try to keep it brief here. I sent some slides, but I'm not sure if you can see the slides, so I'll just try to talk to the points I wanted to make. Nice to meet everyone. Thanks for inviting me. Yeah, as Doug said, I'll just talk briefly about one of the standards that we have, that we often use here, that actually was led by NREL in its last revision, IEEE 1547, which is basically IEEE's flagship standard for integrating distributed energy resources, DERs, with the power system and making them, available to the smart grid as resources. So this standard basically deals with anything that can export power connected to the distribution system. So that could be solar, it could be vehicle to grid, it could be energy storage, it could even be rotating machines. And it's been around for a long time, but it went through a major upgrade a few years ago to make it more compatible with the concept of smart grid. One of the key things that it includes is sort of this fundamental idea that if you're going to have a bunch of resources on the distribution system that are contributing to distribution system needs or bulk power system needs, the first thing you need to do is make sure that those resources are able to stay online when there are disturbances on the grid. So we call this ride-through. And so it has pretty robust ride-through requirements so that, if there's a fault somewhere else on the grid, that you don't have the solar or vehicles or whatever else is providing services trip offline. This is good for the owners of those devices, but it's also good for the grid because it helps the grid remain stable when you have lots of these devices on it. So that's the fundamental piece that's in there. And then the other piece that it has is, one of the other pieces that it has is the ability to autonomously sense the local conditions. So a solar system with an inverter could locally sense that there's been a change in voltage at its location, at its terminals, and it could adjust, for example, its reactive power to help push that voltage back towards nominal. Similarly, if it senses a change in frequency, it could adjust its active power autonomously without any signal from anybody else to help bring the frequency back towards nominal. And so that's sort of the low-hanging fruit that I think is in IEEE 1547 and in some other international standards as well. So that's something that I think is available to be taken advantage of today to help the smart grid work better as we start to get more and more distributed energy resources. So that's one piece that's in there, and another piece is the ability to actually use communications to control those devices. So IEEE 1547 requires that all DERs be capable of communicating using at least one of 3 different communication protocols that then would allow a utility or an aggregator or someone else to control the DERs to obtain whatever benefit you're trying to obtain for the grid operations. It could be maintaining power below a certain level or above a certain level, or providing grid services or these kind of things. So those are the basic capabilities that are in IEEE 1547, the 2018 version that is now used in maybe about half of the US states. A lot of those states are already taking advantage of some of these advanced capabilities I talked about, especially the autonomous capabilities where the inverter just senses its local conditions and responds in a way that's helpful to the grid. The rollout of communications is, I'd say, probably at a lower stage of maturity, just because someone has to actually build out and maintain and develop that communications network. But it has a lot of potential, I think, to enhance smart grid capabilities. So that's just a really quick overview of 1547 itself. We could talk about it for hours. But I also want to point out that there's an ongoing revision right now to 1547. And you know, you probably know 1547 was developed primarily by North American stakeholders for North American grids. And so if you want to use it in another country, it should be adapted just to meet, as the previous speaker was, as one of the previous speakers was saying, a volt is a volt and an amp is an amp. The volts in India have, the voltage in India on the grid tends to vary over a little wider range than it does in the US. Nothing wrong with that, but what that means is that if you're going to use 1547 and it has specific ranges of voltage defined in some of the functionalities, that those ranges need to be adjusted for the Indian context. Similarly with frequency. It seems like it would go without saying, but it's not always done, and so it's worth pointing out that now in the ongoing revision to 1547, we have an annex that will describe, in a general sense, how you might want to adjust the ranges to adapt them for a different context. That annex was actually developed as part of the work that NREL was doing with several Indian grid operators in the Indian Bureau of Standards. If the slides that I sent can be made accessible, there's some links to various outputs of that work, one of which is a document describing some DER best practices for India, as seen by that project team, and another one specifically talks about how you could adapt 1547 and use it in the Indian context as sort of this foundation of a smart grid. So hopefully those links can be made available to the attendees if they'd like them to be. That's basically all I really wanted to say. I'm happy to stick around and talk more, answer questions if people want to, or go into more details. But basically, you know, it's an opportunity to use a standard that could be foundational to a smart grid in the Indian context. And I think I'll leave it at that, unless anyone has questions. Thank you.
I think that was a thank you, Andy. I don't know if you could hear it, but appreciate it.
Thank you.
Thank you so much, Mr. Arendt, as well. Now we would like to move ahead with Mr. Miguel Martinez. He's the Senior Business Manager at ULSE Solutions. We would like to invite him to share his recommendations for a safe integration of DERs. Thank you. Miguel, are you online?
Yes, I'm here. Can you hear me?
We can hear you.
Okay, perfect. Okay, thank you for this opportunity to talk on this event. I think that I hear the previous, the people that talk about the different solution that we have at EAC or at North American level. I think that it's a good moment to talk about what we are doing in Europe as to show what is our actual implementation. At the European level, I think that our opinion at the European level is that it's well developed because we had a long experience with integration of this type of generators. At European level, our work to do is, I hear sometimes some reference about the standards. The standards are very important, are useful, and are needed for the market, but at European level, we define at the first the regulation. The regulation is fully implemented. We have two types of regulation, one for generators that was implemented in 2016, that this is the commonly named requirements for generators. And this European regulation is mandatory at all the European countries. and define what are the regulation or what is the requirement, sorry, that all the generators need to comply to be connected to the electrical grid, from 800 watts up to no limitation of power. At the same year, we create another regulation, it's the demand code, that define the requirements for this electrical, for small grids and for all the big consumers that connected to the electrical grid. Based on this regulation, each European country developed his own local requirements, but define it in this framework. So this means that we have more or less a common solution at European level for all types of generators, with the difference that shall be included for each country, as each country has different electrical grid. So the requirements in Germany that is very well interconnected with the rest of the European countries shall be totally different than the requirements in Italy or in Spain, that we are isolated from the electrical point of view. So this regulation affects to all the range of power. So we are talking about residential, industrial, and utility scale level. And it's defined in each country based on these requirements. Depend on the power, you have some requirements that you need to comply, and with the maximum power or voltage connection, you need to comply with the maximum requirements, maximum number of requirements. This document is alive. This year, we are planning to do an update at European level to introduce something that will be crucial for the smart grids. One is, for example, the requirements for EV chargers, that you can imagine that there are a lot of installations at European and worldwide level, but this requirement not only affect to the vehicle to grid, this requirement affect to all type of EV chargers, and define the requirements to not be affected for any change into the electrical grid, and to give more capability to the utilities to have direct connection with this type of generators, in case that is bidirectional EV chargers. And the second topic is the implementation of storage systems, that as I said yesterday, it's important to provide this support to the existing renewable energies, because we have the dependency of the primary source, but if we have this storage system, we can work more independent of this primary source. And with this storage, we can provide the grid forming capabilities to the generators, to these inverters or wind turbines, to have the same behavior of the synchronous machine. So it's a great opportunity to manage and to handle these capabilities and this interconnection. So with these three new pillars that will affect to storage, grid forming, and to EV chargers, we can handle the generation and the consumption of the energy in a more controlled way. Of course, there are some requirements new that will be affected to the heat pumps, but this is for the demand connection. We need to control that, and after any change into the frequency, there are some consumption reduction by these heat pumps to not affect to the electrical grid. So if we combine all of these requirements, the application for the different type of generators, because these requirements affect for all type of generators, including nuclear power plants or other type of generation, we can have more capability to control these systems. And if we have this system controlled fully for all the European countries, we can handle in a smart way the control of the electrical grids. We need to consider that the requirements for EV chargers, you know that there are some cars that has embedded this EV charger. So it's important how to handle this control for all the cars that are moving inside Europe. At European level, our way to work is based on this regulation. We create some stakeholder committees with association of generation, with certification body, and with utilities we are handling at this moment the development of the certification scheme. to do a common framework at European level. So we have the regulation, we have the standards created at the international level, EAC, and transferred and adopted at national level, at European level. And after, we will have a certification scheme. So we will have this standardization work down country by country or at European level, because we have solutions at European level for grid code connection. But the other thing it's very important is to have defined the conformity evaluation scheme to not duplicate or to not to have a common framework at European level. And more or less, this is the summary that the actual activities that we are doing in Europe. I am working very actively in the standardization side, doing the requirements for grid code connection of all type of generator according 5549. And I am a co-chair on the stakeholder committee that are developing the certification scheme for grid code connection of EV chargers and headpumps. Thank you.
Thank you so much, Miguel. One quick question, if you have any recommendation document that you can share with us, and we can further share it with the group that we have today, that would be highly appreciated.
Okay, I think that my presentation from yesterday, it's a good summary of all of the topics that I explained today, so I think it's a good document.
Okay, sure. Thank you so much. And I would request Miguel and Andy to, if they could stay a little longer, so that when we move to the panel discussion, and if there are any questions for you, you can take that up. Again, I would like to thank you for staying up late and being a part of this important discussion. I would now like to request Mr. S.K. Senapati, Head Sales and Commercial Services for Larsen & Toubro PT&D Digital Solutions, to share their thoughts.
I just had one comment for Andy. I'm Ravindra from IEEE India Operations. Yeah, this is not working. Hi Andy, this is Ravindra Desai from IEEE India Operations. Yeah, sorry. Hi Andy, I am Ravindra Desai from IEEE India office. Just for your information, thanks for the work done by Andrel, yourself, McKenna, Killian, or Powell, and your interaction with MNRE, CA, and other Indian agencies. IEEE 1547 is already adopted by India as Indian National Standard 18968. In fact, there are 3 standards that are adopted. So I thought I'll update you. Thank you.
Great, thank you for the update. I appreciate it.
Yeah, thanks.
Thank you, Ravindra. Senapati, sir.
Yeah, good afternoon. I'll just, first of all, thanks US Commercial Service, US Embassy, and ISJ for this opportunity. So I'll just directly go to the point. So today the discussion point is the driving safer and secure smart grids. So most important thing here I have to highlight, you need to adopt a open protocols like IEC 62850, DNP3 for your real-time monitoring and interoperability. So in the utility side, a lot of things are being done. So like in France, a lot of digital substations. We did also with 5 different makes of IDs, interoperability. But I think more focus has to go to the DRs there. Second point is, okay, we are talking about interconnection of DRs to the grid. So they're all unified interconnection protocols has to be adopted. I think we are doing that. 1547 and defining the voltage and frequency limits. So it varies from country to country. And I think my co-panelist highlighted that. So US, India, or any specific region country, you can define, set the limits. So these are the 2 points, but most important thing is today, any fault happens, this should be a provision also to auto disconnect, and there should be protocol. So that you need to adopt. So auto disconnect of the DR from the grid. And islanding state, it should be safe. So these are the few points. Then we all know, okay, it has to be secure, then the cyber security aspect has to be there. And most important thing is that today we are talking about Surya Har Ghar Yojana, so rooftop solar. So somebody has to integrate, sell the power in the peer-to-peer trading platform, P2P trading. So that has to be embraced, and protocols has to be defined. So because we have to adopt that. So so peer-to-peer trading. So these are the few points I thought I'll highlight. And apart from that, whatever DRs we are adopting, it has to accommodate your VPPs, your EVs, EV charging stations. So those protocols has to be also clearly defined. And I think my co-panelist also indicated, okay, it's not only V2G, V2X. So some of the states in California, we are doing those studies with California Energy Commission. So it is all not V2G, V2X. So you can give to the grid, you can give to the home during wildfire. So those bidirectional power flow protocols has to be clearly defined. So I think that are the good practices what is being adopted globally. So and we need to be harmonizing those standards while implementing these microgrids. And those standards should help us to implementation of these DRs in lesser time and cost-effective manner. So these are the few things I thought I'll highlight in this forum.
Thank you, Mr. Senapati. I would now, as we concluded our panel discussion, let's move ahead with the roundtable discussion. And for that, I would like to invite Mr. Manjunath to lead the panel discussion. Thank you.
Thank you, Anisha, and thank you all the panelists who presented their experience, whether it is the IEC harmonization related or the work that has been done in US, how they have been able to create or some recommendation document with reference to what India should look at with reference to whether it is the voltage regulation, the frequency regulation. I think the islanding is another thing, and the number of DERs coming in. How do we really harmonize the way it has to be integrated, which has been talked about. And definitely, Senapati sir, the point which you brought out with reference to the Indian context, which is going to be most important for us to see. What we had done last year in the month of December, we had a similar roundtable where it was more intense discussion to bring out what are the various challenges. The points which came out very evidently, particularly with reference to DR, and as you talked about the Har Ghar Surya Muft Bijli Yojana, which is going to add in so many points, and if we miss out on the safer integration, it's going to be a huge challenge, and I think we should address it at this right time. Few things which brought out was voltage regulation, the voltage fluctuations which talked very eloquently here. And also they said that because the Indian grid, the voltage fluctuations being so large, how does the smart grid, the inverter that we are using would really address what kind of protections that it would have. Because one of the things which you, Senapati sir, you talked about is how do you cut off or what kind of safety measure that you would include. Similarly was with reference to the grid instability, which is like disconnection immediately in response to a minor grid disturbance, or the sudden loss of generation causing significant fluctuations in the voltage and frequency is going to be another challenge. The cascading failures and the protection coordination, which is going to be the most important thing because you have got multiple things, and definitely the talking about power quality and the frequency regulation, which I already talked about. So what we thought is it's going to be good for us to answer these questions which has been put on the screen also. However, I'll read it out for all of us to debate. The basic intent of this roundtable is to make sure that we have the constructive dialogue for us to evolve a solution and make recommendations like what Ashok Rajput sir was telling, and also the intent with which BIS is being here, because they have done a remarkable job in terms of having the standard being adopted with the India differences. However, until and unless it gets translated into implementation with the right regulation, which has been already talked about both Miguel and Andy, so it is going to be essential for us to address these questions. So first question what I thought we should really look at is what's needs.
Sir, it will make the discussion more meaningful if I make two small remarks.
Yes, sir.
V2X is much talked about.
Right, sir.
Now supported with the standards and protocol. But since ages we have the V2X. Could you get a clue? Motorcycle battery
being used
to run the television.
It's the V2H which has been done.
V2X.
Yeah.
V2X we have since long time, right? You go to small camps, we have the batteries or something, and there we use. That is V2X. Biggest example, or I can say the contribution I made to this e-mobility business is, I suggested long back to World Energy Forum, and they happily agreed that tractors should be converted and should form part of the e-mobility business. They are there because it's a very versatile equipment there, and India needs it. It is India specific. I do not know how other countries are doing it. DER we have, but in isolated form. But now the need is to devise it more scientifically and in a more safer way. Remember, one particular entrepreneur having a small DG set, supplying with its parallel wire to each and every home a limited quantum of the load, and if you exceed that, the switch will trip. That was the simplest form. Need is to there. Yesterday also I told that there are 6 lakhs of the villages, and we are aiming 500 gigawatt of RE and talking a lot about it proudly.
Yes, sir.
Of course, the proud should be, and proud should come as early as possible. 6 lakh black, even if you say, realize 0.5 megawatt of the electricity sources through RE of different bigs. We are talking of the hybrid and this and the storage. Divide the means, divide the separate modules. Your 300 gigawatt is readily at your palm top. Okay, whatsoever the land is there, create the trees and the carbon sinks with a huge investment there. Whatever you are making, the large plants and all those things. I don't deny that their importance is not there, but this importance is also there because it will reduce the burden on the grid. And most of us, you must have read, or those who have not read should read the books by Turan Gonan, a very good electrical engineer. He wrote long back that the next era will be that of dispersed and distributed generation coupled with DMS and overall EMS.
Yes.
DMS is the distribution management system and overall EMS is the energy management system. And the concept of DSO has to come, which we are neglecting in all through our discussion. Distribution system operator. Because the things may be there, things may be installed, they may start generating, they may be feeding the grid, but somebody is there to control them. And when you come to the distribution, there is a phenomena of single phasing, two phase and three phase. It's a mix of that, highly unbalanced system, load are unbalanced, network is asymmetric. That need to be taken care of. Yes.
Thank you, sir. I think the point which you brought out with reference to V2X, yeah, it's little complicated than what we had used earlier, because today it is not just the V2H, it is V2V, V2G. When it comes to V2G, their challenges come because it has to be integrated with the grid. I think the points that we are talking about here is going to really look at all of that, because even in the V2X, what we are looking at, a converter or something, because vehicle system is a different one. I'm sorry, am I audible loud enough? Okay, so the microphone is not working, and let me stand also. It's okay, sir. So what would be essential for us to really look at is how does it integrate, how does it integrate with the grid, and also it talks with the vehicle, which is again a robust system. So that's the point, and I think it gets very well related with the DER system that we are talking about. How do we really look at? So the points which were really brought out was, let me read it out. I think it's quite far, and the smart, while we have developed this standard and we have already adopted it, how do we really look at grid code and the integration this with the grid code and the regulations that need to be brought out? First question, or the first point that was talked about, is the smart inverter's ability to match, be compatible with our grid profile. So is this a real challenge, right? So in that case, what do we do? Can we have some thoughts? And let me bring my microphone there.
So far, so to give you a bit of my background, I've been working into rooftop solar installations. So the upfront grid instability or any problem with the DR assets, I can actually say a lot about it, what kind of services we have attended to. Other than that, we are also making solutions, hardware and software solutions for DR monitoring and control. So at this point in time, matching with the grid profile is not really an issue. Most of the inverters come with the grid profile integration. However, it needs to be done manually. In case the inverter trips, somebody has to inform you, and then you have to go and do it. It's a manual task, and you need a technician for that. Other than that, in our experience, so right now we are trying to install solar monitoring hardware for about, say, 500 plus inverters. So we have figured out around 7 OEMs and 18 inverter brands at this point in time. The basic mapping is flawed to the extent that even with our best intentions, I cannot control the inverter. Few of the inverters mention it very directly, what can be done, what cannot be done. Other than that, we were also helping Reggie sir to identify a smart inverter for UL testing. That was a whole task in itself. I had to reach out to about 20 plus inverter brands. Nobody could figure out what 1547 is. So there's a immense amount of unawareness at this point in time. Also, some utilities have started coming to us in order to be able to use these inverters for the grid flexibility services. We are trying to find the best inverter brands that we could figure out, but because of the lack of information amongst the inverter community, this is not even a dialogue. So we should have more inverter participants in meetings as such, where they could understand what this means. All of the inverters from where I believe are being supplied to US or Europe market. So most of the inverters are actually compliant with all these standards. It's just that the APIs or the protocols are not upfront available for us to operate on.
Thank you. Thank you, Archie. Any?
No, go ahead. Go ahead.
Thank you, sir. Thank you, sir. Actually, what I see here, inverters are smart, no doubt, but there is a challenge there. What is the challenge? So today we are talking about, okay, we have to deliver to the grid with a ramp rate of 10% or 5% based on the country grid code requirements. But my SCADA PPC gives a command to the inverter, start or curtail, generate or curtail. But okay, my thing will be, my cycle time will be maybe 100 millisecond max. But while going to the inverter, oh, it's not that great to respond to that. So what happens within the whole cycle, the response time is getting defeated. So if you have to really deliver to the ramp up or ramp down, then we are not able to do. Then there is a challenge to the grid. So I'm facing that subject in India, in Saudi Arabia, I have not got my update from the US side, which we are also doing. I think we need to look at that.
So, just to add whatever Sinabhi Sahib has told, see, there are two things. When we are putting this inverter, and I know NREL is doing a lot of work on this, the grid forming inverter as well as grid following inverter. So black start capability is another one of the important issue which we are talking of here. And NREL and many researchers in India are also working towards that. But another important aspect which you have categorically pointed out, one is the response time or the ramp time of the inverter pertaining to the grid condition. And please try to understand there are two things. When we are talking of the rooftop solar, and even if in a village there are 300 small homes are there having 3 kilowatt, so all are having different load profiles and grids. So that's why whatever Rajput sir has told, the most important thing you have to look into the grid profile and all these things, and Indian grid code. That is another important aspect. So that's why the topic is very important, harmonization of all these grid code, looking into the Indian condition. Like in the EV, we are talking of the condition which prevails in European country, American country, and in India are completely different. So that's why you have to look into that. And the third issue which is very important is the protection issue. Because everybody works in an isolated manner. For example, the inverter, they design the control in the PQ mode or the voltage following mode, stops there. But nobody looks into what is the protection issue there. It has its own protection inside that. The current level goes more than 1.5 unit per unit or 2 per unit, it cuts. But what is the effect on the grid? So that's why a systematic study, while framing the standards also, is very, very important. Look into the use. And both are very important. The low level as well as the high level inverter, the way it works and all these things, that is very important aspect. Yeah.
You want to continue on the same point? Yeah. Okay, you go ahead. I'll wait.
Okay, I just wanted to carry forward what Mr. Panigre
Sure, go ahead.
In fact, this protection and measurability, what we are talking about the smartness. The smartness is basically what you can see, sense, measure, can decide upon, control, and use. That is very important because in India, generally people they don't use. Since systems are installed, there is no sustainability of the system. So capacity building is one of the things. The point which I am trying to make, the hard truth is that basically in distribution system, which we are having right now in our cities, almost out of 4,000 towns which we are having only 50 towns where automation is there. Hardly. It is even lesser than that. That is a hard fact. And we are talking about the smartness to the level of consumer. I think we have to bridge gap first. That is the very important thing. What we need to do is, if we are going for a smart inverter, we have to go for a full-fledged automation. That is for the up to DT. That is the SCADA, DMS, OMS system has to be in place in the towns. And I would like to say that because we are the nodal agency for Government of India Power Finance Corporation. So basically we are responsible for, providing the system, facilitating the system across India in 4,000 towns and villages also. It has to be extended to the villages. And also support solar. So these are the things. So we cannot go in silos. We have to see, if we are talking about smart inverter, where is the gap? Gap has to be seen. That has to be bridged. So this is very important. Another thing is, we are not a very cash-rich country. So we cannot have a very fancy technologies. We have to have indigenous technologies with low-cost solutions. Being in India, we have tried to even automate low-cost solution. Like we have a SCADA DMS. With SCADA DMS, we are having very, very good SCADA DMSs across the world. But we are trying to do an indigenous version of our own, as China has done it. So this is very, very important for a self-sustainable basis. Not to offend someone, basically, but this is the hard fact. When you are going to Atmanirbhar, jaise bolte hain, then Atmanirbhar will come only then when you are self-sustainable basis. So we are trying to use. One more thing which I am trying to make here, small things you take as a smartness, like smart inverter one thing. There is a protection requirement for Indian context. For example, how many people dies every year just because of shock, electrical current shock. That is only 5 milliamps basically, but it is fatal. What happens? People dies, cattle dies. What we have done, we have devised a small smart system, which is also integrable with the SCADA system, only for 3,000 rupees. What it is doing, it is giving you local alarm, it is giving you alarm at the control center, it is going to give you basically everything on the local side, crew management, and so that you can prevent such kind of mishappening. So this is very, very important. So what I am trying to say, whatever standardization we are doing, whether it's smart inverter, in smart inverter, unless we have a visualization, what data it is getting, as Mr. Panigiri has told, that what are the factors, whether it is voltage based or what kind of production, we will not be able to take guide. Silos will not happen, should not happen. We have to think in a collaborative manner. Thank you.
Thank you, sir. Thank you. I think
you raised very valid thing that it should be affordable, which you want to say, and that I fully endorse. Things should be affordable, then only it can work. Another thing is maintaining the system thereafter, and who will maintain that system? Very good system can come, but who will maintain it thereafter, say after 5 years, after AMC is over? And another thing is the spares. How do we get the spares? Life of the device and the system, the total system. One more thing is, yesterday also I raised harsh ambient conditions. We are designing for which ambient conditions? Our equipment, our controllers. These are all having many electronics devices also. Whether we should adopt the military grade or something else could be done which could serve our need. That should be the main objective. Thank you.
Thank you, sir.
Yeah, so I think let's take a step back. I think there's a major confusion. We are talking about smart inverters and where we are coming from. This 1547. Is it made for the home inverter? Rooftop solar for the homes? No, it was not designed for that. Now we are mixing the same standard for residential rooftop, this thing, which is absolutely disconnect. So I think this standard was for those string inverters, grid inverter, which were batteryless and all that. So and which was pretty fine. Today, what we need in India and all that, har chat pe solar and all that. If we are looking at that, and this discussion has been going on since I think more than 10 years. We had even with the Smart Grid Forum a discussion in Chennai once. I remember 2014. The point of rooftop solar for a domestic, if I look at it, there one thing is the rooftop solar inverter which are available for domestic as a thing. They are fixed frequency in India mostly. So they need to be grid sync. Okay, on that, you guys have no issue, but I have issue because I have been designing those inverters for the last 30 years, and most of the inverters are fixed this thing. But when they need to work with this thing, grid sync is first thing. Second thing is, now we need an islanding for that, and the islanding control has to be with utility. Because if I am having it on my rooftop and my home, I have a battery. Second thing, they need to have a battery backup. String inverter do not consider battery. If there's no grid, the inverter will switch off. All the energy will be wasted. In India, we have lot of time. Grid is not there. So where does the solar energy go? We should be able to store it. And in case of domestic, we need hybrid inverters where we can store it also. And when we store it, now what will happen? 9 o'clock, my inverter, my battery starts charging. 12 o'clock, 1 o'clock, it gets fully charged in summers. Now it will simply start uploading. And at that time, if there's someone, lineman is on the operating, they're switched off from the grid side, from the substation side. But there's no switching off from the residential. He'll die of a shock. And this point was discussed in 2013-14. Nothing has been done. And beyond that, now we have the smart inverters have a lot of processing power. And it should not only monitor one energy, we should have the integrated metering engines also for DC, energy metering, AC, whether it is up or down, and even for consumption side, it can work as a really smart inverter for the consumer also, which will give him, energy management at his steps that he can manage whether he wants to add charge battery, whether he wants to upload, whether he wants to give it to neighbor or those kind of things we are looking at.
Home automation
Home, because that is also needed. Today, if you're talking about every rooftop, what Mr. Ashok Rajput talked about, so much of is available. This is the major volume in India for the market, for business, for everything, which nobody is talking about. And for that, you need detailed specification, not a very high level standard. This is a good standard. But then this is out of a very different context. And I think we should not mix up two different contexts.
That's why the point I told. You look into where you are doing this. Whether it is a home inverter, which you are talking of maybe up to 3 kilowatt, or you are talking of a large power plant. And then again, when we are talking of the standard, the integration of the DER or inverter based or non-inverter based.
And one last point only. One last point. Communication protocol and data. That is very important aspect now. If it is your string inverter, which is only going to talk to the grid and all that, then you need those communication protocols and data models. But if it is going to talk to the smart homeowner also, then we need some harmonization of the communication protocol, data models and all that, which nobody talks about ever. Because these products come with different kind of protocols. Or some people come, inverter manufacturers will have their proprietary protocols. We need to standardize a whole lot of things. Walk quite a lot of miles.
It has to be vendor agnostic, basically. That is another.
We are talking of the solar inverter integration, and same we are now going into V2G. So when we are talking of V2G, also we have to be very clear. Is it a individual residential vehicle is feeding to the grid, or it is an aggregator, like the parking lot or something which is feeding to the grid? These two things are completely different.
May I suggest we do not get into that vehicle right now? The first problem is, I'll tell you what, first problem is the buildings. First problem is the buildings and the homes. Can we address this thing first? If we get into vehicle mode,
that's right. Because the discussion was on that. That's why these two are separate things. That's why I'm telling. Low power inverter used in the home may or may not need synchronization. Large, where you need sometimes synchronization, they're isolated.
It will need. You will need.
Upload the energy.
Manjunath.
No, what we need. 12 o'clock my battery charge. What do I do with the...
Kishore sir, I think the point is well taken.
Just very small intervention. Manjunath ji.
Yes sir.
Very small intervention.
Yes,
what professors have said,
yes,
and respective Panigrahi ji. And thing is that if we talk of V2G, it may be too early for us, right? We should learn from others, those who have.
I think that is the intent.
In V2G, we can do immediately one thing, whatsoever the swapping models are there, and where the large centers of the, say, charging the batteries for the swapping models. So there we can integrate those to the grid, and that's a very good feature, and we can say normalize what is known in electrical engineering as the power system, the smoothing of the load curve.
Point well taken.
That
sir.
we should focus.
Yes, sir.
Instead of one small vehicle and doing how much it will give.
I think I'll talk about that also, sir, as we move on forward.
Touched the point, sir.
Yes.
The point.
Because of the bulkness, basically, in the bulk, there you can swap the battery.
हाँ.
Service provider who's going to provide.
अब वो हमारे रेस्पेक्टेड शर्मा जी को चांस दीजिए इस बार. मैं सिफारिश कर रहा हूँ क्योंकि उनका नंबर हमने कई बार काटा. ठीक है, सॉरी.
Thank you, sir. At least we are thankful for U.S. Commercial Services and ISGF for organizing it. In fact, we have gone through this pain because we also tried to harmonize the standards of 5.6 utility which we TPC had. And it is a huge discussion as it is happening here. But before that, what we have learnt out of that, there has to be standardization on few more things. Like Mr. Richard said, that this is to be, apart from product, this is to be system also. So we have to see the regulation which are there, the financials which are there, which is already talked, that we have to see the cost also. And then comes the technical and the product. So probably three, 4 things have to move simultaneously if we really want to achieve the standardization. So for example, the present regulator says that DER, which is a distribution energy resources, say if we have as a DISCOM, if we have a 50 MU DER available, he is using a DISCOM system as a best, like battery energy storage type of thing. He is pumping the energy during the day, say 50 MU is pumped during the day, and 48 MUs he takes out. The net consumption is only 2 MUs. But this is what? This is like when I'm excess of energy, I'm storing it. When I'm have a deficit of energy, I'm using it. So probably the standard and the regulator has to think about it, that somewhere this cost has to come. So that also has to be seen from that perspective also, that how we regulate. But as far as standards are concerned, it would be easy that whatever upcoming things like V2G is there, P2P is there. So all these things which are really developing right now, we work on those technologies and we provide the standard. Rather than we go backward one by one, probably that would be the right choice, in my opinion.
Thank you, sir.
Yeah. So I will talk mainly on 1547, but before that, since we are talking of harmonization of standardization, I think 1547 is a good example. It gives not only a reference of IEEE standards, but it gives reference, or it refers to 61850, that is IEC, UL1741, NREL, FERC, ANSI 84. So all it is like a system. So whatever is useful, it gives reference of that. Okay. It has provisions for all. Like it gives the requirement for operation, performance, testing, maintenance, safety, and interconnection. Okay. Panigra sir was talking about auto disconnect, anti-islanding right through. So it has the provision. It is only like facilities are there. Standard will define the provisions. It is for the manufacturer, smart inverter, to have that, and it is for the regulator to make it mandatory or regulation, and for the utility to use that.
No, there's an issue. I'll tell you what. Yeah. Like a smart meter, we have a standard, but which is more closer to specs. Then only you can have interoperability, you can have standardization, where you can have vendor agnosticity. In certain cases, normally standard by default are voluntary and they are common minimum. Okay, but in certain cases, when you really have to address some crucial problems, you need to go a bit granular into specification, mandate those, and then the standard has to be mandated. Then only those things will proliferate. Otherwise, you will always have disconnect in the market.
Absolutely right, Kishore.
Like 1547, okay, it talks of some over voltage and over voltage, under voltage, over frequency, under frequency. But in US, what they use is two level, 1.2 and 1.1. Even for frequency, it is two level. Whereas whatever India has adopted, it is one. Provision is there.
India-centric condition is important.
So India, that's the whole thing is what we are really talking about. In fact, we really progressed much ahead of what I was really intending, and it was a natural progression. I could see that. Is it necessary to have the battery energy storage system along with all these DERs? Yes. I think that's the most important thing which has been brought out. And what we need to do, is it just 1547 or any of the standard which is already there, or do we really need to do that India relevant integration of the...
We'll need to work further.
Exactly.
We'll need to work further. Beyond what 1547 sets a good baseline.
But the values...
Good baseline, but
so
not enough.
Having a standard, even if it does not fulfill all the requirements, in my opinion, is better than having no standard at all.
No, that we already have it now, Vikram. We already have it now.
No, so you have it, but now the discussion is whether it is meeting all the use cases or not.
So that's the whole, the discussion is whole about that.
No, it is not.
Yeah.
There you have to refine something.
So all the manufacturing community and the user community, they have to come together. Manufacturer will look for innovation. Manufacturer will look for economies of scale. User will look for user will look only for safety, reliability, and interoperability.
So interestingly, this standard has been discussed only in ETD 46. Okay, which is a grid integration committee. No, but there is another committee which has done ETD 28, which is on solar inverters and solar panels. So the solar energy, it should be discussed there also if as a product.
So I think it is a role that all the community here has to fully support BIS to make it work.
No, BIS is our platform for financial.
I just want to add on. There is a provision in 1547. There are three different categories. Category 1, 2, and 3. 1 is minimum integration. 2 is medium, 3 is large. So accordingly, provision should be used. Provision is there. It is only for the utilities and regulators to use. Thank you.
Ravindra, the point I think what we are really talking about is a standard is there, but is it implementation ready? I think that's the question that we are asking, and I think the points that have been brought out with reference to the features that we are talking about, what is essential for us to mandate and how do we make it ready for regulations to be brought in is the question. Thank you very much, because I think the next question which I had was, is 1547 what we have adopted is good enough, or do we really need to have something which is India relevant? I think we already arrived at it, and also the point which you brought out with reference to that energy storage system has to be mandated, whether it is the large system, because large system, by the way, it goes with it. However, for the smaller ones, which we are going to be in millions, because I think 6 million is the number that we are really looking at, and look at what would happen if all this, any one thing goes wrong. I think our grid is going to suffer, which is going to be a real big challenge. And thank you for really progressing much ahead of what the questions was put in. I think I have summarized some of the things, and let me go to the next bit, the third.
Only 1 minute, not more than 60 seconds. As rightly pointed out by Vikram Gandotra, instead of having no standard, let's have some standard. Let's start with bare minimum requirement. Then slowly, once the system matures, I think we can go ahead with more features.
I don't agree on this. I would like to contest this point. I'll tell you why. We already have it now. But the point is, can we start the business? Can we start deploying them? No. We need more granularity, more clarity for the product people to develop, design and manufacture products so that they can be deployed. We need more clarity, more details to come up for the manufacturing ecosystem. So it is not deployable the way it is today.
So Manjunath, I mean, very pertinent things which are discussed, but one thing which I think needs and which connects everything is the case studies. You know, currently I think UL is rightly placed along with the SAE and others, wherein you can come out with the real world case studies, what thing impacts how, what are the parameters which are already being covered, the parameters which needs to be covered within these three definitions which we have. And that's where the point which Mr. Narang has brought about, that what are the things which has to be followed. Again, my opinion is totally different in terms of the standards and the standardization. Of course, I am not too much in favor of the standardization, but minimum standard for everything is there for sure. And as and when the industry is ready, you know, the market decides. In some certain cases, it has to be forced by the regulator, but in most of the cases, it should happen on its own. Market should decide. This is my opinion, which is totally different. Of course, it comes from the larger perspective which you understand from the government of India also.
So market should decide is a very interesting statement, and I hear it even from startups and researchers that innovation, standards block innovation. So I have a counter argument for that. But if your definition of innovation and market should decide is my shade of green and my shade of blue, I'm sorry, standards do block this kind of innovation, and they must be there. But the point is, if really our standards provide you contours of structured innovation, and that should be understood in a
exactly. Yes, so actually what I think what has been brought up is standardization is going to be driven by the market, because they are going to look at the commercial aspects and bring it. But standards are the one, as you rightly said, they are the one which is going to drive the innovation, because they are going to give what are the basic minimum requirements, but as the things evolve, it is, yes. So, and definitely what Randy sir said is right, that we need to really look at standards first, and standardization gets driven on its own. Neha, you wanted to make some comment.
So I've heard everything, and I feel that there is some lacuna on the part of the implementation of this particular standard 1547. So yeah, BIS has achieved this milestone that we have adopted this 1547, not just adopted, but we have modified all the requirements to cater the Indian grid conditions to 50 hertz and everything. But there is no point if we are not able to implement the standard. It will just make a part of the repository of the BIS document. So through this platform, I just seek support from all the concerned stakeholders, the academia, the everyone, all of you to please come forward and tell us the challenges that you face while implementing these standards so that we can always improve upon. Because standardization is always a dynamic process and we seek your support, your inputs, because you guys are in the field, you know whatever the challenges are there and how we can improve these standards. So through this, we seek your support, your input so that we can improve these standards and it can be implemented. Because at the end of the day the aim is to make the grid more stable, more secure, to make it more interoperable. And for that, if we need to develop more and more standard, then we need to come together at one platform, because this technology is rapidly evolving. And sometimes it becomes very difficult to standardize the innovative technology when the things are changing very rapidly. So for that, we need to come together, we need to bring all the challenges on the table so that everything can be incorporated well into the standard and it can be implemented at the end of the day.
Fantastic, thank you.
What,
I think we'll just, yeah.
Yeah, what ma'am Neha has told, just I want you to say everything. Like the gap which we were talking about, basically it seems to be because like generation, transmission, distribution, all are working in silos. So there is no common group which is also having industry representation. Also, the financing institutions, all these should come together in a group and then they should work together, not in the silos. So then these problems can be seen.
Again, I think I'm so glad that the questions that I had for us to answer has naturally progressed.
Without asking.
I request Banju to share email ID of Neha so that all can post the challenges which she can address.
Yeah, let's have
No, so she can help address. She can't address.
Yeah, we will take help of the expert.
We understand that.
And through standard, I think I feel that all the challenges can be addressed. But that those challenges needs to be bring on the table. Unless we will not be able to tackle all of these situations that you guys are talking about.
Yeah,
so that, for that we need your support.
Neha, if I can come in here, this is Abhishek. So the point is we can't have the ideal utopian perfect thing in the first place. We can't have that. Even the electricity grid, the distribution for example, is evolving. All the regulations or standards, if you see the last 2 decades, the first version and the latest version will never match. There have been so many changes due to many other factors. I'm not going into technical details. So if BIS has already brought out the first, if I can say, the first version of this, adopted it, the idea is to test it on the field, maybe in a sandbox. Now, regulatory commissions would have to be brought into picture. If I talk about DER, integration into the grid, and we need these standards to be adopted, even in a sandbox. So there are ways and means of doing it in the system. For example, I don't know if we have approached CE, Rajput sir was here I think, where there's a CA technical regulation, we all know, like distributed generation resources connectivity to the grid, what are the standards? If it is adopted and written that this so and so BIS standard has to be referred to or should be complied with, makes the job easy. So what happens is any regulatory commission, they come out with their distributed generation regulations, net metering regulation or otherwise also. It refers to applicable CEA technical regulations. Job becomes easier. One thing is, if not blanket adoption, it could be said that, okay, on a sandbox basis, we allow this to be and then let there be some DISCOM or DISCOMs willing where it can be implemented and present to us the outcome of the same. Maybe in shape of a report, what was some of the use cases which can be discussed, like utility scale we have voltage right through, HVRT, LVRT and reactive power, the basic things. If you are requiring that also in the distribution grid where it is more DER rich, let it be demonstrated and then come back to us. So otherwise we'll be sitting on the table saying that, okay, let that ideal regulation or ideal standard come into place and then we'll start. Nothing is going to happen like that, okay? So yeah.
Absolutely. I think the easiest thing would be, we already have 1547. We should map the use case which fit to it as of today and then move to the next level of use case. Sure.
Yeah, so we are already doing a UL testing. We have sent in some smart inverters. Now, what you were just telling me, so one of the smart inverter companies that we'd been able to send, initially the team here didn't realize what 1547 was. However, that inverter is extremely, extremely smart. It's one of the best of its kind. The major thing was whenever I came up with, so see, this is a standard. This could basically like stand you out in the whole architecture. They're like, no way. I'm already at like selling at rock bottom prices. You bring in another standard, I cannot afford in this country. So that's the kind of mentality we are having at this point in time. So first of all, there's no advantage to market participation. That's another problem. One thing Serge suggested is sandbox. This is something we've been talking to for a lot of these platforms. There should be an active sandbox where you should have this data coming in. Utilities can come and play with it. You know, let just not be a literature or report, nobody goes through it. Let there be an active thing where the smart meter companies, everybody can integrate. Once they simulate, once they see what they're actually capable of, they can act on it. And these aggregator services will only be able to increase the deployment of RE in general, that we have seen. Like everybody wants to make use of this data. There are a lot of market, so there's a concept called unified energy interface that is basically bringing market discipline in general, and it's making it very easy for these DL assets to come play in the market and also increase the deployment. For all of this, the major issue that we've been facing once we are going out there is how do you integrate all of this? We are talking about hardware at the same time. It's not just not software. So this integration is something, a standard would really help us as a startup or as an aggregator, a checklist to follow, where we can expect the smart meter companies and everybody to come on board without much resistance.
Thank you, Arshi. And yeah, sorry. Yeah.
I think that last one.
Yeah, sorry. So maybe just a couple of reflections listening to the conversations and thinking about where research in the U.S. is. And Andy can compliment me if he has other comments. He's still online, by the way. One is that we are working very diligently across the TSO, DSO, DER interfaces, and that I would encourage you to think about power systems standards, not just DER standards, and that it needs to be holistic from anything that is connected to the grid. All the way up. So that's one particular piece. The second one, and I just verified this with Andy, is that I think even 1547 and other standards need to continue to evolve to require, I'll call it future proofing, i.e. the ability for software upgrades as technologies, solutions, regulation, business opportunities continue to evolve. And this is a very important element because there are examples around the world where inverters in particular were not software upgradable, and they were huge, like millions of truck rolls in order to go out and upgrade them. And that's frankly just not a good thing to do these days. And then the third thing I'll just put forward is the conversation right now is about what you're facing at the moment. Yeah. And if I think about the research that we're working on, good colleagues, Andy's and others, are actually working on standards for grid forming inverters. And so now you get to the whole next phase of what does a system look like, self-healing systems, which we've defined algorithms for, or NREL has, et cetera. So thinking about what does a roadmap of standards look like as the market evolves and as policy and regulation and business evolves, I think is a very mindful thing to do. And there are lessons to
Thank you, Douglas. Thank you for summarizing and what really we need to look at. I think Murugesan sir wanted to make some comment.
My name is Murugesan, former Director General CPRI, and we were involved with smart grid development standards. Yeah. Actually, we are from I am from CPRI. We have been trying to evolve the standards for smart grid systems, starting from home automation to AMI to feeder automation, then distribution automation, substation automation, SCADA, electric vehicle or storage, all such things. So, we are trying to see that there is a ecosystems around IEC. you see that there are all the standards like especially IEC 61850. So we need to have all interconnection. Nothing, no standard is standing alone. If you take AMI meter standard, then above that, that has to work on 61968, which incorporate all distribution automation standards, about 10 functions. So it is not that one standard, it stops with one. So if we come to this 1547, this is aligned with IEEE 2030. That is IEEE 2030 is a framework for smart grid standard for America, in the sense USA had done it, and 1547 is specifically meant for interconnection. And IEC 61850 is born out of USA. It is nothing but UCA 2. So there is a connection between IEC 61850 and 1547. But beyond that, they have their own standard. We talk about all smart grid standard 2030. Most of the standards are USA based. But what we have is, we have a combination of IEC, and all our standards are combining with IEC standards. If you talk about electric vehicle or AMI or substation automation or SCADA, all talk about all as IEC standard. So here only advantage is that the 1547 has the data model and profile model which is aligned with 61850. Many people are not even aware of what is that standard, the protocol, all such things. So we need to see that when I introduce 1547, there is a transition. Equivalent standards are available. What IEC is offering for the ecosystem of smart grid, we need to see that, map it. Otherwise, it will be difficult for ordinary Indian customers.
Thank you, sir. Thank you for getting all these standards that are already available, and how do we really look at. I think that is an additional point beyond these challenges that we are talking about and which has been already faced, and also the point which Douglas made. How do we really look forward than addressing only the current challenges? With that, Richard, you wanted to make some comment.
A quick comment. You did something great already, which is choosing one standard. Fine, I'm not commenting about the choice. There are many standards. You've been choosing this one. It is as it is. You've been able to make it evolve, to take into account something specific to this country.
Yeah.
But the discussion I hear is really about, hey, okay, there is a standard, but how can I use it? How should it be used? We have to keep in mind that the standards are here to serve the applications. They are not there to tell us about our needs. Yeah. So basically, what I've been hearing here is the need for, at minimum, a user guide, a companion document. But it's more than that. It's more than that because there is safety involved there. And this is where a grid code is needed, actually. It's as simple as this. Take any standard as it is. You don't need to evolve the standards, no, take it as it is. But then you need a guidance that should be mandated about how to use it. And even incorporating immediately things that you would wish to see in the standard that are not there. It is as simple as this. And then you can go back even to the IEEE group maintaining their 1547 to, over time, ask them to embark maybe parts of your grid code.
Grid code. Yeah. Thank you very much, Richard. Yeah, you want to make a comment?
Just more than comment, I would say one reflection based on what they said. I think you need to have a balancing act, like, in terms of, making sure that the vendors who are supporting the ecosystem, as well as the utilities, and then everybody else, get to a win-win situation. So in addition to having a standard, you need to specify a common minimum set of requirements that's like, somebody should implement, so that there is some kind of like a common framework across the board everybody can adhere to. Beyond that, like, you don't need to kind of like boil the ocean, beyond like, everything in there. At least like that common, set of requirements, that everybody can adhere to. And that should be fine, because then vendors will be happy, because then it makes their life easier, because they don't need to put all the bells and whistles in their product to meet the cost parameters.
And it would allow also having a test lab, bring their value and be able to industrialize the way they can assess the fact that this has been well implemented.
Thank you. Thank you, Richard. Now, I think all of us talked, and please go ahead, sir.
So, Richard, I would like to compliment you. This is Salesh Gupta. I'm from JSK Industries and also Vice Chairman for EMA Conductor Division. So, I would like to compliment what you rightly said. Although I came from the transmission sector, that is for the overhead network, which is way, way beyond the discussion what we have today about the RE inverters and batteries, etc. But yes, the need to follow a particular standard and make all utilities or the user group to adhere to it. It is very, very important. And I'll give you the case study of the recent case study of India. There is a total, as of now, if we know about the HTLS conductor or the high ampacity conductor, to achieve the target of 500 gigawatt of RE energy, the Indian transmission sector has geared up to scale up themselves to the high ampacity conductor, which is a HTLS conductor virtually. For that, there is only one standard, ASTM B987, in place as of now in the world. So, the industry has requested the competent authority, that is CEA, to make such kind of guidelines, so that the guidelines has to be make a sort of advisory issued by the department and the ministry itself from the policy makers, so that it will make the life easy of the transmission companies throughout the country. And with that, with the help of that, the execution of the projects and the finalization of the bids, because India is following the bidding system, right? It's not like Europe or America, but here we follow the bidding system. So it makes the life easier for all the manufacturers, whosoever is manufacturing the carbon core, that which of the standard has to be followed. And if there are guidelines from IEC, IEEE, even I request BIS also, since I am also a member of ETD 37, that the standard has to be as per the Indian requirement. And BIS has to gear up to finalize the standards and give it back to the Ministry of Power and simultaneously to CA. And it has to be like an advisory to all the utilities, like IDA has just made, if we all know, All India Distribution Association. So distributors, I think Mr. Ranjan is the treasurer for that. No? Okay. So, I'm sorry. But I heard that somebody from BSC has become the treasurer of that. So, huh? Yamna, okay, fine. But what I'm trying to say, it is a very much needed to adhere to that, to stick to that particular standard, that this is the minimum requirement to follow, so that the standardization has been done in the system. Thank you.
Thank you, Shailesh. I think as we move on to the conclusion, now I think we really brought out all the challenges. No, sir, I would not conclude. What I am asking is, so what I am really asking is, it's good to hear all the challenges, it's good to hear all the suggestions, but it is important that how do we contribute to this? Because it's good to be getting along in a forum, talk about it, but then how do we really take it to an implementation level? I would seek inputs and the volunteers from here, so that you say, okay, this is where I would like to contribute, and let's form a group which will continue to work on this, come out with, probably next year when we meet here in ISGF, this bilateral workshop. I think we should be talking about a new challenge rather than talking about the same challenge and how we have addressed. And also we keep seeking the benchmark or the case studies from the other countries. We can become a benchmark or create a case study for the rest of the world. So I'm not leaving you just giving your suggestions and challenges. I am also seeking your volunteerism. I mean, need not be now itself. However, we'll create a link so that we will send you that. please volunteer or please nominate. I know all of you are going to be very busy, but you can nominate some of your team members who can contribute to this. And we come out, we can take a timeline by which we should be able to come out with whatever the challenges and solutions.
There is one suggestion.
Yes, sir.
And, and what Shailesh ji told, we had, or in particular, I should not take credit, but I should boast of. Took lot of pains, took help from IIT Mumbai also, and what he told that CA brought out some guideline and lot of hue and cry were made against that. So that's a different thing. People will say you do some good thing, there will always be a people or a group of people to criticize you beforehand. Okay, so no fear. So first the fear should go out when you are working. You should be independent, clear, and should have a vendor agnostic thing, what Falya ji told, Sharma ji told. So that is one thing. There are some groups which distort the thing and misrepresent, still misrepresenting, and still being taught. Teaching has to be there. For that, what has to be done, and is very important, Professor Saab can help us, and like other academicians and the bodies like ISGF and BIS, we should design some courses and the syllabus. Of course, some are running, but not in most of the engineering colleges. The courses which are to the specific needs. So those course books also first to be designed. Actually, the course books or whatever these latest new things are being taught in the colleges, in the UG and PG level, they are mostly from the IEEE papers and other journals, to which the students community usually don't have the access. So if they are in the textbooks and the simplified form, the further learning can be done through the classroom helps and others. And people like us, who are neither can go to the school and colleges, sitting here only, they can borrow the books from the colleagues or can order online and can read something. So course book formulation and a small guidebook formulation is a must. And ASTM V987, of course, very, very old standard, not updated so far. That updating is also required. IEC made some attempt, but that is a TS only. What people are misrepresenting in the outside world, that it has become the specifications. So it's not that, it's a guide only, not a standard. Standard means it has to be followed like a standard only. And the guidebook cannot be referred, and guidebook is for helping dissemination of the knowledge. When the guidebook becomes mature and the lot of implementation have taken place, then it has to be converted into the standard, and of course after an elaborate process of the voting. That thing has not been done. Bidding are being done based on that, okay, the TS has come and now it has become the standard. That is what the misrepresentation is being made even to the highest bodies, and I am not naming the organizations. The organizations are treated to be the most knowledgeable in this Indian world, and doing consultancies also here and there, right? User groups for that has to be there, and whatsoever the standards we are making, IS has made it a very simple thing. If the indigenous standards are there, they are provided free of cost. That has improved the working level, that has improved the knowledge and enthusiasm of the working level. Otherwise, there used to be days which standard to follow. It is costing thousands and thousands, and it's not accessible. Only the institutes can do. And a specific request to BIS, we have requested through a list in their national action plan about 2-3 months back, and prior to that also, and as a reminder also, to formulate the standards on the specific needs, which through the standardization cells. Actually, for your information, sir, in India, each and every ministry is having a standardization cell. Like our power ministry, we have the standardization cell, and all the utilities are the members of that standardization cell. Being, say, having a nodal person like me, earlier I was dealing, now the another person is there.
Ashok, sir.
So that listing is there. We seek that what new standards are to be formulated.
Ashok,
And
sir,
where
I
the
think,
amendment is required.
sir,
So that is the process going on.
sir, yeah, well, I think that's a point which we can definitely talk
Yes.
later on.
Yes.
So before we conclude, again, as I said, we have made note of all the things. What I would, next step is we'll be preparing a report and sharing it with all of you. And also I am looking at forming a working group, which is by ISGF, BIS, ULSE, IEEE, 4 of us put together. We'll look at forming a working group which is going to work on 4 different areas and how do we address them and come out with a solution, and how do we really make sure the regulations are being brought in, not just the standards and also the guideline that we talked about. Thank you very much for a wonderful participation. A huge round of applause for a wonderful participation. Thank you very much. And just before we conclude, I would like to request that there is a small memento which has been given. All of you, please take it. This is just a laptop sleeve so that you are going to remember that this is the discussion which happened whenever you can pull out your laptop. So, and before that, I would also ask Anastasia to give the concluding remarks. And I would request all of you to join us for a group photograph. I will try to accommodate everyone, maybe over there. Thank you. Anastasia, over.
Okay, thank you so much. I know it's the end of over a very long day, and it's been a very vibrant discussion. But I do want to thank everybody on behalf of U.S. Department of Commerce Commercial Service for your, especially the speakers who have dedicated their time and came prepared with all these wonderful talking points, but also highlighting that each and every one of you has been a speaker today, right? Thank you so much for contributing to the discussion very passionately. And a special thank you for UL team for trusting us, for working closely hand in hand with us to put together this, the list of people in this room to create this dialogue with us. And also we're very fortunate to work closely with ISGF, and Reggie is here now, so thank you so much for being here. He's got a wonderful team. Year after year, we work with them to create opportunities to have a platform for these discussions, learning from each other, for stakeholders both from US and India to come together and have these dialogues. I think one can tell that we've definitely accomplished our goal today. The discussion has been more than I think I've seen in many different roundtables. Thank you so much for all of your contributions on this. I've heard some very interesting points, particularly, I do like to kind of listen and gather at the end what the points are, but you know, the market customization, India's needs and affordability, maintenance and evolution and future vision for delivering this space. But Mr. Barleyji said something that really caught my attention. Thank you so much for saying that. Think in collaborative manner, right? I'm going to leave you with this, but I'm also going to add to it. Don't just think in collaborative manner, please act in collaborative manner. And from that on, let's...
Thank you very much. I think it's very, very... And you said something which is remarkable. I would like to draw attention that in 2023, August, we started and we initiated something on the EV and EVSE safety. And that is the day when Chandrayaan was successful and it landed on moon. And today, it is Sunita Williams and the team who landed on the earth safely. I would like to conclude with that. Thank you very much.